Hi folks, so the question we have in front of us here today guys is from the oblique planes topic. It's from your DCG workbook page 109, it's oblique plane sheet 9 and it's to do with cut solids by the oblique plane. So the question says, given is the plan of a prism which is cut by an oblique plane VTH, the prism is 50 millimeters high, complete the elevation of the prism when cut by the plane, and then it's saying use the pictorial view down here obviously to kind of represent that as a sketch. So what we can see here guys is the elevation, we've got our vertical trace, we've got our horizontal trace, we can see where they are on our sketch down here, vertical trace, where the oblique plane cuts through the vertical plane, horizontal trace where it cuts through the horizontal plane. We've obviously got our solid here, and in this view we obviously have the bird's eye view, which is the plan view of that solid. Now we have to we have an oblique plane, that is cutting through a prism that is 50 millimeters high. So what we're going to do is we're going to draw in that prism in construction lines, at a height of 50 millimeters, and then we're going to find the points at which it is cut at, So we're going to start off there by projecting up my lines up to the vertical plane. So the elevation there, I'm going to project this one up, goes up about 50 millimeters. My red lines here are my construction lines. So somewhere up there about 50 millimeters. I'm going to measure 50 above that then. So there's my 50. There we go. So there is our prism. Just put them in completely. There is our prism completed in our elevation view. And I'm going to label this as well. I'm going to call this front face here, this one number 1, which will be there. So I'll call this number 1 there. Then this one be 2, 3, and 4. So likewise over here, 1. I'm going to put 2 here, 3 inside here, and 4 out here. So at that there, we can obviously see 1 here is the front edge. That one there, 1 completed in a while. Obviously it's going to be a cut surface somewhere along these edges. But 1, would be up here. 2 is this one. 3 would actually be at the back. That will be in hidden detail. And 4 is out here on the right hand side. So what we actually have to do here now, guys, is we have to find the location of where the oblique plane is cutting through the prism. And if we think of the prism, guys, this top surface here, if we look straight down on top of it, even after it's cut, we're still going to actually see, we're still going to see a square, 1, 2, 3, and 4. So our plan view is not actually going to change here. It's just our elevation view that's going to change. If there was no oblique plane cutting through it, this would be our elevation view, But we know there is an oblique plane cutting through it. So with the principles we've learned in previous parts of this topic, what we're going to do is we are going to use point location to basically determine where along line number 2, line number 3, line number 1 and line number 4, where they are cut, And 2 is obviously cut at this point here, So it's just a case of determining where the oblique plane is cutting through exactly. So what we're going to do is we're going to take a horizontal cutting section, a horizontal cutting plane to determine that. And we know when we take a horizontal cutting plane, that will appear as a parallel line, parallel to our horizontal trace in our plan view. In our elevation, it will appear as a horizontal line. So, parallel to the horizontal trace from 2, and where it hits the XY line, I'm going to transfer that straight up. So I'm going to transfer that straight up to my elevation. Where it hits the vertical trace, transfer it across. And that there helps me locate where exactly that oblique plane is cutting in my elevation for point 2. So I'm going to call that 2 there now. Alright, I'm going to do the exact same method then for 1, 3 and 4. And I'll take it one at a time. So, parallel from all the points to the horizontal trace. So I'll do for 1. I'll do it for 3, and I'll also do it for 4. And there now, we're going to project up our points. This is for number 1. Project it across to number 1, which is on this line here. Okay, so there's number 1. Mark it down here. I'm going to do number 3 next. So you can see 3 parallel to the horizontal trace, because it's a horizontal cutting plane. We're actually using that principle here. 3 went up to hit the vertical trace and will come across. Only comes across a slight bit, so it's going to come in there. So there's number 3. That's where that's cut by the oblique plane. And finally, last one, number 4. So number 4 goes up, comes across, and there we go, number 4. And we know then we just have to connect them up. So I know 1 connects to 2, 2 connects to 3, 3 to 4, 4 back to 1. So I'll connect them up there quickly. Four to 3 and 4 to 1. And now I'll heavy in my edges going up and down. It's 2, they all connect to the XY line because they're all touching the ground. 3 we know is in hidden detail, so I'll put him in at the end. I can see 1 as I look directly at the face of it. And I can see 4. And I know 3 then is going to go in as hidden detail. The reason for 3 going in hidden detail is because as I look in this direction, obviously 3 is at the back. Okay, and what we've actually got here in this place here, okay, that is actually our cut surface that has been cut by the oblique plane. Okay, so if I was to represent that over here, just to give you an idea, I'll actually try and mark it now with roughly determining the height. Okay, so for each one, we can see 2 is the lowest, so I'll see where 2 is here. So I'd imagine 2 is about somewhere like that. 1 is the next height up, the next lowest, so it's about, I'm going to say something like that, about there, on the 1 line. And then we've got 3, which is, I'm actually going to put that in on the back edge, just to give me a little bit of a guide. Okay, and I can see it's parallel with that, it's roughly 45 degrees, it's about there. Okay, just to give me a guide. Okay, 3 is a bit higher than 1, so went up that height, it's going to be up about here. So about there, I'm going to guess. And then 4 is close enough to the top, so it's about here maybe. It's about there. Alright, and with that being our cutting plane, so okay, I'm going to connect them up. What we would actually see in the pictorial view over here is something like this. Okay, that there, this little irregular shape that I'm putting in here, is basically what we would see of our object. I'll heavy in these details here. Of our object, once the cutting plane, the oblique cutting plane, has cut through it. Okay, and as you can see, it has removed all of this top surface here, and that's actually what we're left with. Okay, and obviously what we see then over here in our elevation, this is our elevation and our plan view of it. The plan view does not change, as you can see. Okay, you're still going to see a square when you look down on top of it, even though we can see it's obviously a cut surface. Okay, and what I usually do is when I'm doing a hatched view or something to show something is cut, I put in some hatching lines to represent that. Okay, just to identify that this is actually the cut surface. Okay, that is done by the oblique cutting plane there. Okay, a little bit in that there, guys. It's just point location, but understanding obviously that we can use these points 1, 2, 3 and 4 and just use the normal method of point location by taking a horizontal cutting plane to locate it. Okay, not too tricky, just a little bit in that and the understanding of how to do it. Okay, so what we're going to do now, guys, is we're going to move on to question 2 over here. Okay. Right, folks, so in this question here, we can see that we actually have a cylinder this time that is cut now by an oblique plane. Okay, so if I was just to put in, as best as I can there, an oblique plane, just to show you that. Okay, and as you can see, we then have the cylinder that's inside of our oblique plane, and it's obviously going to be cut at an angle. So vertical trace there, horizontal trace there, and the XY line here and here. Okay, vertical plane VP, horizontal plane. Now what we want to do is inside here we want to basically show where that is cut. And anytime you have a cylinder, okay, a cylinder is actually created by something known as generators. Okay, so if I was to put in a line here, okay, just a line like that, and that generator, starting here, if it was to revolve around, okay, a circle, the path of a circle, okay, obviously in this pictorial view we see it as an ellipse, but if that generator was to go around like this and around, okay, what shape it actually generates is a cylinder, okay? So we're just going to use that method, okay, and we're going to create a load of generators to do that. So often when we have circles, what we're actually going to do is we're going to split it up into 12 segments, okay? So 30, 60 through it, so 30 degrees this way, 30 degrees this way, 60, and then 60. Everything through the center. And having done that now, I'm actually going to use labels. So I'm going to start with, I'll use like a clock. I'll say this one is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so I've labelled them 1 around to 12, okay, like it is on a clock. And what we're going to do is we're going to also locate those generators. Now that's the plan view of them, okay? So for the sake of it, that's the actual line that I'm representing here. I know this is on the top surface and it looks like I've split that, but at each one of these, if I was to say this was number, for the sake of it, I'd say that's number 7, okay? Technically, which 7 is here, that's a line running down along the outside of our cylinder. So if I was to project 7 up, okay, and we can see that 7 is actually in line with 11, okay? If I was to project that up, that's actually what we have, okay? So 7 and 11, that's what we have. I'll also project up 8 and 10, project up 9, and we can see 9 is with the outside of it, so that's absolutely fine. 3 is with the outside of it here. And project up 12 and 6 together. 1 and 5, you can see that they match up with each other because we split it up at 36 degrees, and then 2 and 4. Okay? And that's basically the idea there. You don't actually have to do the lines up, just as long as you recognize. You can see that I was showing you 7 matches up with 11. So 1 to 5, I've just kept it neat and tidy there. I know 1 and 5 are there. But to save me now, what I could actually do as well is use labels, okay? So I know I've got 12 and 6 up here, so I'll start with 1. So I know 1 is opposite 5, 2 is opposite 4, 3, I got 6 and 12. So 1, 2, 3, 4, 5, 6 and 12, 7 and 11, 8 and 10, and then I've obviously got 9 out here, just so I know which ones are there. Alright, now what we're going to do is kind of like the previous question where we used point location, okay, and the last time what we actually did was we used horizontal cutting plane to basically do it. This time we're going to use it doing a vertical cutting plane method, okay. That means, okay, that our lines, whenever we hit the XY line with some of our points here, they're going to go parallel to the vertical trace, okay? Whereas in the horizontal plane, okay, which is our plan view, they're going to be parallel with the XY line, so they're going to be horizontal, okay? And the reason for that is because we can actually, you could do it the other way, but the reason for that is because just because 1 and 11 they match up, 2 and 10 match up, 3 and 9, 4 and 8, 5 and 7 and so forth. It actually limits the amount of work that we have to do. Otherwise we would have to go parallel from every point to the horizontal trace. So you'll see there I'd have to do 8, I'd have to do 7 on its own, 9, 6, 5, 10 and so on, okay? Whereas in this way, if we go using the vertical cutting plane method, we actually get 2 for the price of 1, okay? So if I just show you there, we'll start with number 12. With number 12, I'm going to project across horizontally, okay? Where that hits the vertical trace, what I'm going to do is, the horizontal trace, I should say. Where that hits the horizontal trace, I'm going to project up to the XY line, and where it hits the XY line, I'm going to go parallel to my vertical trace. Just like that. And going to go up to where it hits number 12. And we can see I've now found where 12 is at the exact point when it has been cut by the oblique plane. Okay, so that's my 12 there. Now I'm going to do the same then for 1 and 11. Okay, so you can see here I'll do the same for 1 and 11. Because you can see that they match up with each other perfectly. So that's 2 for the price of 1, as I was saying. And where it hits the horizontal trace, project up. Okay, and then where it hits the XY line, I'm going to project up parallel to the vertical trace. So 111, so there's 11, and there's 1, and find my points. There's 1, there's 11. Now I'm going to actually speed up the video, guys, because it's just that same process the whole way around to locate my 12 points. Okay, so I'm going to speed up the video there now. Right there. So as you can see, guys, I have now found my 12 points, 1 or 12 all the way back to 12, and what you'll actually notice is just in the first couple when I was explaining them, and as you can see when I speeded up the video, I did the lines the whole way across, okay, as far as the one when I had to find number 3 over here. And then when I moved on to 4 and 8, you can see I went across to 4 and 8 here, where it hit the horizontal trace, went up vertically to the XY line, and then when I projected parallel to the vertical trace, I just marked it on the 8 line and then on the 4 line, okay, just to keep my drawing, okay, because you can see there's lots of lines going everywhere, okay, just to keep my drawing neat and tidy, as you can see. So you can see it was parallel to the horizontal trace, so I did that with the last half of it there, okay, and that's basically the idea. Now at this point, guys, we've actually got the cut surface of our solid, and what we're going to do is we're going to sketch that in, that profile in there, okay. So I'm just going to speed up the video while I sketch that in there. Right, guys, there we go. That is the question completed there. A little bit in that, guys, in comparison to the first question that we had done over here. In this one we use the vertical cutting plane method, and in the vertical cutting plane you will always see a vertical cutting plane as a horizontal line in your plan view, whereas in your elevation it will be parallel to the vertical trace. Alternatively, obviously in the question over here, question number 1, we used a horizontal cutting plane where it was parallel to our horizontal trace and plan, and then horizontal in our elevation, okay. So there's a little bit in that there, guys. I'm not going to do the sketch, guys, but you'd imagine obviously we'd have some form of an elliptical shape over here, as we can see there. That is our cut surface right there, okay. Hope that was helpful, guys. Now we're going to move on to question 3 at the bottom left of the page, okay. Right, folks, so the last question on this page, guys, question 3, it says, this rectangular base pyramid is cut by the given oblique plane VTH. Produce an edge view of the oblique plane and hence locate where the pyramid is cut on the plane VTH. Now, we are going to basically have to get an edge view of our oblique plane, which is actually going to show us the inclination of our oblique plane to the horizontal plane. It's basically going to show us the oblique plane as a line, and we'll be able to see the angle it makes with the ground. Now, the reason we actually have to do that is because we are actually dealing with a rectangular base pyramid here. Now, the problem is, like in the other questions where we did the square base prism and we did the cylinder, in those they were vertical solids, okay, they were standing upright solids, but obviously as well the line on the prism were just going straight up. The problem is here we have angled lines, okay, obviously for the pyramid. So we can see obviously from the base of the pyramid where there's 4 corners, every one of them is running up to the apex, okay, at an angle. So that way we actually cannot locate where the cutting points are on this. So because the thing is, I don't know the cutting point, because I know this point right here, okay, is a definite point, but it's on the ground, okay. So if I was to project up, let's say parallel to my horizontal trace, then go up vertical to where it hits the vertical trace and then come across, that does not actually prove that that is the cutting point, okay, of where the oblique plane is cutting through my solid. Likewise with this one, and this one. Okay. So what we actually have to do is we have to get an edge view of the oblique plane, and then project up an auxiliary view with that of this structure here. Okay. So I'm going to start that there now. So I'm actually, first of all, I'm going to label my drawing, and I'm going to call the top of it here O, and I'm going to label these four corners A, B, C, and D. Okay, so I'm going to start with this one. I'm going to call it A. I'll label it inside here. I'm going to call this one B, this one C, and this one D. Okay, so labeled here as well. So this one down here is A. We obviously have B there, so B here at the back again, and C is out here, and then D. Okay, so what we're going to do is we are going to project up, and what we're basically doing is we're looking along our horizontal trace. Remember, your horizontal trace is on the ground, so that's actually a true length there. So we're going to look along our true length to see it as a point view. Anytime you look along a true length, you will see that true length as a point view. So I'm going to project up there, just a little bit, just like that, and then I'm going to set up an x1, y1 perpendicular to it. So literally, I looked along with my 45 and then I just literally rotated it. I'm going to set up an x1, y1 to it. Okay, keep it out here. Okay, I think, yeah, that should be enough. And I'll call that x1, y1, and that there, right there, I'll write it in, point view of HT, of a horizontal trace, HT. Okay, point view of HT, right there. Now, like we have done in previous questions before, what we're going to do is we're going to take a height or a point, okay, from the vertical trace. It's going to take it about, you can do it anywhere along. I'm just going to do it in green here. Just going to take that height right there, okay, because I know that point there is a point on the vertical trace. Picked it anywhere, could have done it here, it doesn't matter. And what I'm going to do is project up from that point, parallel to the horizontal trace, from where the point is on the XY line. I'm going to mark that up, out there I think. And what I'm then going to do is, using my compass, I will take that distance here, the height up there, follow that up to my x1, y1, mark it, and having marked it there, that is the height. That height is the same as this height here. I have now found a point on my vertical trace, and remember this is the point view of my horizontal trace. Therefore, I'm actually seeing my oblique plane here as an edge view. So I could actually call this V. So it's VTH. Okay. So I'm going to write that in here. Edge view, oblique plane. Hopefully that doesn't get in the way of my drawing now in a minute. Okay, so at this point now, what we're going to actually do is project up all our base points, A, B, C, and D, plus the actual apex O. And I know all of A, B, and C, and D are on the ground. So A comes up to here, that's where A will be. I'll do the same, D is actually next, so I'll just stick with that. So D is going to come up to there. Okay, trying to keep this neat and tidy as I possibly can. B is going to come up to there, and then C out to there. And I know O is the only one that has a height. I forgot to actually label that at the start, sorry. O is up there. So project O up, and somewhere up along there is my O. Okay, so the only one I actually need the height for, the vertical height is, oops, drop the set square there. The only one I need my vertical height for is O, so I'm just going to mark that. So O obviously comes up to there, checks up, and I'm going to take the height from here up to here, okay, on my compass. Just grab my set square there. So I'm going to grab that height on my compass, project from the plan, take your heights from the elevation. So O is down here, follow it up, and there's O, right there. And I can mark that. That technically would be called O1. So down here is, I'm going to mark it A1. Then I've got B1 over here. Out here is C1. And I've obviously got D1 right here. Okay. So you remember now, we're not looking obviously in this direction, we're looking along HT. So I'm actually seeing the face I would see the face ODA to a certain extent. I'll probably see the face ODC. The faces I won't see are OAB, they are still there, and OCB. Okay, so just take that into consideration when you're heaving in the detail. So I'll bring all these up now. So I'm going to bring O up to A. There. D, B, and C. Okay, and I will heavy in, so I would heavy in O to A. I'm only going to heavy in this much of it. I'm going to explain why in a second. I would see D, yes. Would I see B? No. So that will actually go in as hidden detail because it's at the back. And would I see C? Yes. There we go. That is our object, okay, when we have actually taken here what's known as an auxiliary view, okay? So auxiliary, obviously, guys, is just another view, okay? And as we see, the reason we actually had to do this is because now we have the oblique plane as an edge view, okay? We are seeing the oblique plane as an edge view, okay? We're not seeing it kind of like this anymore. We're kind of seeing it as a line, something like that. And that line we can see is cutting it at an angle, okay? Something like that. But more specifically, we've actually located the various cutting points. We've found a cutting point on the line OA right here, OD right here, OB here, and OC here. So where we have found them, we can now project them back to our plan view. So like we projected up, we're now going to project back. Okay. So I have found the point there, cutting plane, that's on the line OA. So very important, that is my cutting point right there for the line OA. This one is for the line OD, so just make sure you're getting the right ones. That is my cutting point there for OD. Okay, in plan. This one is OB. And obviously I think you'd be a little bit more accurate if you're using pencil. I'm using biros here. Just make sure there looks about right. Okay, and then finally we have OC. And there we go. Okay, so there's our OC right there. So now at this point I'll heavy in my plan. First of all by heavying in the actual cut surface. So now this one connects around to here. This one connects up to here. And then this down to here. And I can now heavy in these edges. Okay, so there's a little bit in that there, guys, just having to actually take the auxiliary view in this case. Okay, and that's my plan view of it got. Okay, so this cut surface here, we can see obviously the top of it has been cut off. That's seen obviously over here as an edge. Okay, and now what we want to do is we want to project that back up to our elevation. So where I found let's say the line O down to A, I want to do the exact same. So it cuts it here, so project that up. Project that up to there. The line OB, which is at the back, goes up to there. The line OC, which is this guy. And then the line OD, same place, so it's about there. Grand. Happy with that. So it cuts there. There, there, and there. Okay, so just have to heavy that in my elevation as well. So this is the elevation view of that cut surface. And once again, have to heavy into detail, looking in this direction now. Okay, so I would see the line A up to O as an edge. Okay. I'd see the line D. Okay, I would see the line C, yes. And then we know already, because they actually have it in here for us already, but the line OB would actually be hidden detail. Okay, so you can just go over that yourself there. And there's our hidden detail, guys. What I would usually do at this stage, guys, as well, is if you have a pencil, it's always helpful. Okay, I'm just going to use my green kind of biro here and go over it lightly. So I'm just going to speed up the video while I shade this in. Okay, that is the question completed there, guys. As you see in there, just when I speed up the video, I'd always use a colour keep colour handy, be it any colour, doesn't matter, okay, something different to what you're using. But I just shaded in the area there, guys, in both my elevation and plan, just to show where the oblique plane is cutting, okay, the actual solid in those positions, okay. And just up here as well, I wrote in cut surface, obviously, just to show where it cuts from the oblique plane. Little bit in that question there, guys, just being able to use an auxiliary view, just understanding why we had to get the edge view of the oblique plane. And the reason for that was it determined our specific cutting points on this rectangular based prism, or rectangular based pyramid, I should say. Okay, hope you found that helpful, guys. That is the last question completed there on that page. Okay.